Hello everyone, and welcome to another video in our Excel VBA tutorial series. In this video, we're focusing on how to automate Google Scholar data extraction with Excel VBA for academic research. This tutorial will guide you through using Excel VBA to automate the extraction of valuable data from Google Scholar. An essential tool for both students and researchers, we'll cover how to efficiently harness VBA to control Internet Explorer, ensuring a seamless data gathering experience. Whether you're aiming to streamline your academic research or looking to enhance your VBA skills, this tutorial is crafted for your needs. So get your Excel ready, and let's dive into these powerful and practical automation techniques. Now, let's take a closer look at Sheet 2 in our Excel workbook, which plays a crucial role in our data extraction process. This sheet is specifically designed to capture and display the data we will be extracting from Google Scholar. First, notice how we've organized the sheet. At the top, we have input cells where you can enter your specific search terms and set the number of pages you wish to scrape. This allows for customizable searches tailored to your research needs. Then we have the status indicator cell. This cell updates in real time as our VBA script runs, providing you with immediate feedback on the progress of the data extraction, such as which page is currently being scraped or if the process has been completed. The main part of Sheet 2 is dedicated to displaying the extracted data. Here we have different columns labeled for titles, authors, content preview, and direct links to the articles or papers. This structured approach not only helps in organizing the scraped data effectively, but also makes it easy for you to analyze and utilize the information after extraction. Also prominently placed on this sheet is the Run button. When clicked, this button triggers our VBA script to start the scraping process. It's a key element of our user interface, making the initiation of our data extraction as simple as a single click. Before we proceed to the VBA module to explore the code, it's important to note how the design of this sheet is thoughtfully aligned with our script's functionality. The organization and presentation of data here are directly linked to the way our VBA script processes and writes the information. With this comprehensive overview of Sheet 2, let's now move on to Module 1. I will guide you through the VBA code that powers this entire automation process. Before we begin to explore the VBA code, it is important to remember to enable specific references in your VBA environment. These are the Microsoft HTML Object Library and the Microsoft Internet Controls. These libraries provide the necessary objects, properties, and methods to control Internet Explorer through VBA. Now that we've set up the necessary references, let's dive into the code. We have designed it to be as succinct and efficient as possible to automate the retrieval of search results from Google Scholar for the term we will be using in this demonstration, which is English literature. While this VBA code covers the standard functionality needed for web scraping from Google Scholar, it might not account for all unusual or exceptional situations. If you encounter any errors or unexpected behaviors, consider adding additional error handling to the script. For guidance on error handling in VBA, I recommend referring to our tutorial number 12 titled, How to Handle Errors and Debug Excel VBA Code. That resource is specifically dedicated to that topic and can significantly enhance the robustness of your script, especially for more complex or extensive tasks. Now let's examine how the code works. The first line of our code is a simple but effective way to give us immediate feedback within our Excel sheet. It indicates that our script has started its operation by displaying the word running in cell C2. We then define several objects, IE for Internet Explorer, doc for the web page's document, then results and result for handling the search results. Additionally, we declare variables like I, J, result count, and number of pages for looping and tracking the number of pages processed. The variable data parts is declared as a variant type, which in VBA is a very flexible data type that can hold any kind of data, including arrays. In the context of our script, data parts will be used to store the array of data segments obtained from splitting the inner text of each search result. Next, we initializing an Internet Explorer instance and setting its visibility to true. This step is crucial to allow us to monitor the browser's behavior while the script is executing. If it becomes unnecessary to observe the browser, the visibility can be switched to false, running the code without displaying the browser window. Next, we navigate to Google Scholar by constructing URL with the search term from Excel Sheet 2 cell B1. Notice the replace function. This replaces spaces in our search term with the plus character, which is a necessary format for URLs. Once we initiate the navigation, we have the loop that ensures the page is fully loaded before we proceed further. It's crucial for the stability and reliability of our data scraping. After we ensure the web page is fully loaded with our do-while loop, the next critical step is to set the doc object. We do this with set doc equals IE document. This line allows our VBA script to interact with the content of the currently loaded Google Scholar page. Next, we set the variable number of pages to 0. This variable plays a crucial role in tracking the count of result pages we've processed. The extent of pages navigated depends on the search outcomes and the input from the user in cell B2 of Sheet 2. Now we enter the main scraping phase of our script, starting with the label Scrape Next Page. This label acts as a reference point, allowing our script to loop back and process subsequent pages of search results. Before we begin scraping the current page, we insert a brief pause using the wait function. This 7-second delay is essential, not only for preventing excessively rapid request submissions, which reduces the risk of being flagged for unusual activity, but also for adhering to ethical web scraping standards. By implementing this delay, we ensure our activities don't overload the website's server, demonstrating our commitment to responsible data collection. Therefore, maintaining or even extending this waiting period is advisable to uphold these best practices in web scraping. With our responsible approach in place, let's now focus on the actual data extraction process. The next crucial step in our script is this line. Here, we use a CSS selector to identify all the div elements that encompass each individual search result on Google Scholar. The div.gs_ri is a CSS selector where the dot signifies a class. So this line is specifically targeting div elements with the class gs_ri. This particular class is what Google Scholar uses to encapsulate each individual search result. Now, let's open the browser again to visually inspect a Google Scholar search page. We'll see where these div elements with the class gs_ri are located, and how they correspond to the search results we aim to extract. As I inspect the elements on this page, pay attention to how each search result is structured. When I hover over or select a part of the HTML code, it highlights the corresponding section on the web page. You can see that each search result is indeed wrapped within a div element, marked with the class gs_ri. Identifying these elements is crucial because it tells our script exactly where to find and how to extract the information we need from the web page. Understanding this link between the web page's visual elements and their underlying HTML structure is a fundamental aspect of web scraping. It allows us to navigate and interact with web pages in a targeted and efficient manner, programmatically extracting the specific data we need. Keeping this in mind, let's head back to our VBA script to continue our journey through the data extraction process. After setting the results object with the search results from the page, the next line is result count equals results.length -1. This subtraction is key to accurately processing the search results in our script. Since the collection of results starts its index count at 0, the last element in the collection is at the position length -1. By setting result count to this value, we ensure that our script correctly identifies the index of the last search result in the collection. With the result count established, our script moves into the extraction phase. We start this with the for I equals 0 to result count loop. This loop iterates over each search result that we've just identified. Inside this loop, we first isolate each individual result using setResult equals results.item, open parenthesis I, close parenthesis. This command allows us to work with one search result at a time, extracting its specific details. The next step is to split the inner text of each result. We do this using the split function, with VB new line and VB new line as the delimiter. This approach effectively separates the different components of each search result, such as the title, authors, and publication details, which are typically formatted with double line breaks on the web page. After we've split the search result data into the data parts array, our script moves into another important loop. For j equals 0 to u bound of data parts, this loop processes each segment of data we've just separated. We use the u bound of data parts function to find the upper boundary or the last index of the data parts array. This makes sure our loop covers every piece of data extracted from the search result. Inside the loop, the first thing we do is check if the current data part isn't empty. We do this using if trim of data parts at j is not equal to an empty string. This step is key to avoid adding blank data to our Excel sheet. The trim function cleans off any spaces at the start or end of the data, making sure we only consider relevant information. After confirming that the data part contains valuable information, the next line takes care of recording this data into our Excel sheet. Let's break this line down. The first part of the code line dynamically finds the next open row in the column that matches our data type. Sheet2.rows.count tells us the total number of rows in the sheet, making sure we start from the bottom. The next part, .end open parenthesis XL up close parenthesis, works just like pressing Ctrl plus up arrow in Excel. It moves up the column to find the last cell that isn't empty. The .offset open parenthesis 1, 0 close parenthesis bit basically moves down one row from the last non-empty cell we found. This way, we land right on the next empty row, ready to write our new data. The last bit, .value equals trim of replace of data parts at j, replacing VB new line with a space, is where we set the cell's value. What we're doing here is using the replace function to swap any new line characters in our data with spaces. This makes sure our data fits nicely into Excel without any messy formatting. And then, the trim function comes in to clean up any spaces at the beginning or end of our data. By repeating this process for each part of the split data, our script efficiently writes all the relevant information from each search result into separate rows and columns in Sheet 2. This organization makes the data easy to read and analyze later. After writing the data into the spreadsheet, the script encounters end if, which concludes our conditional check. This line is crucial as it marks the end of the actions to be performed when the if condition is met. The loop then continues with next j, moving on to the next data segment in data parts. This systematic processing is repeated until all parts of the current search result have been examined and transferred to the sheet. This approach allows our script to capture a comprehensive dataset from each Google Scholar search result. Each piece of information is dissected and organized into an Excel format, making it readily available for any further research or analysis. After handling all the text segments of a search result, the script moves on to extracting the title hyperlink. For every search result it processes, the script finds and grabs the direct hyperlink linked to it. This is done by identifying the specific pattern in the HTML structure where the clickable title of each search result is enclosed within a certain tag. Let's now take a look at the browser to see how these hyperlinks appear on the Google Scholar page. This will help us understand the script's method for pinpointing and extracting these links. As we inspect the elements on this page, notice the structure of the search results. Each title of a search result, which serves as a clickable hyperlink, is contained within an A tag. This A tag is nested within an H3 tag marked with the class gs_rt. In the code line, we use a specific pattern to locate the hyperlinks. The h3.gs_rta is a CSS selector, where h3 is the HTML tag and .gs_rt specifies a class named gs_rt. The dot here indicates that it's a class, and the A targets the anchor elements within this class. We then use .href to extract the URL of these hyperlinks. After the script has extracted and stored both the textual data and hyperlinks from each search result into Sheet 2, it exits the I loop. Then it assesses whether there are more pages of results to process based on the user's input. The script keeps track of the number of pages processed through the variable called number of pages, which it increments after processing each page. It then compares this count to the user-defined number of pages to scrape, which is inputted in Sheet 2. If the number of pages processed is less than the desired total, the script prepares to scrape the next page. To navigate to the next page of search results, the script uses a specific command to click the Next button on the Google Scholar page. When examining the Next button's HTML structure, we can see that it's part of an anchor element. Inside this anchor element, there's a span element with the class name gs_ICO_ICO_nav_next, and a bold element that displays the text Next. The span element's class name is crucial for our script to identify and interact with the button, while the anchor element contains the link to the next page of results. In our script, the code line utilizes this information. Let's break it down. The function doc.querySelector allows our script to find the first element in the document that matches a specific CSS selector. Then the CSS selector specifically targets the span element with the class we just found when inspecting the HTML, corresponding to the Next button on the page. The command's final part, .click, simulates a mouse click on the identified element. By executing this command, our script effectively clicks the Next button on the Google Scholar page, triggering the page to load the subsequent set of search results. This action is a key part of automating the pagination process in our data extraction task. Having clicked the Next button to load a new page of search results, our script then performs an update in Excel to reflect its progress. The following line is executed, providing a real-time status update in cell C2 of Sheet 2, indicating which page of the results has just been processed. This is particularly useful when navigating through numerous pages, as it keeps track of our progress through the search results. Following this update, the script then proceeds to the Go to Scrape Next Page instruction. This command is crucial as it signals the script to loop back to the beginning of the scraping process for the next page. It ensures that the script continues to scrape subsequent pages until it reaches the total number specified in cell B2 of Sheet 2. After that, the script reaches an end if statement, thereby exiting the if condition. With all the specified pages now scraped, the script moves towards its concluding steps. It updates cell C2 of Sheet 2 with a final message indicating the completion of the task. This message serves as a clear indication that the entire scraping operation has been successfully completed. It provides a comprehensive summary, letting you know the exact scope of data that has been gathered, marking the successful end of the script's operation. Finally, the script wraps up by performing the necessary cleanup activities. It closes the Internet Explorer instance using IE.quit and clears out any allocated resources by setting IE to nothing. These final steps are crucial for maintaining your system's efficiency, ensuring no unnecessary processes are left running once the scraping task is complete. Now finally, let's see our script in action. We will use English literature as our search term and set the script to scrape data from the first 4 pages of Google Scholar results. And when I click the Run button, our script will begin its operation. As the script begins, pay attention to Sheet 2. You'll see it updating in real time. The cell C2 now reads Running, indicating that the script is actively scraping data. You can see the script is clicking the Next button, automatically moving to the next page of results after extracting data from the current page. Also, watch how the status in cell C2 updates after each page. It's now indicating which page number has been scraped, providing us with a live progress report. And as the script finishes scraping the 4th page, you'll see the final update in Sheet 2, signifying that our script has successfully completed its task. This demonstration vividly illustrates how our VBA script efficiently automates the process of extracting valuable data from Google Scholar. It highlights the script's capability to handle multiple pages, update its progress in real time, and complete the task with precision. This is the power of automation in action for you. Thank you for watching. We hope this tutorial has been informative and helpful in showing you the power of Excel VBA for automating web scraping tasks, especially with a resource-rich site like Google Scholar. Your ability to streamline academic research through automation can be a game-changer, saving you both time and effort. If you have any questions about this tutorial, or if there's anything that wasn't clear, please feel free to leave a comment below. We are here to help, and we'd love to hear from you. Also, if you're struggling with any aspect of your VBA projects, or if there's a specific problem you'd like us to address in our upcoming tutorials, don't hesitate to let us know. Your feedback and suggestions are invaluable, and they help us tailor our content to better suit your learning needs. Don't forget to like this video and subscribe to the channel for more content like this. Your support is greatly appreciated, and it motivates us to continue creating helpful tutorials. Thanks again for joining us in this journey of exploring the capabilities of Excel VBA. Happy coding, and I look forward to seeing you in the next tutorial.